Hello everyone, my name is Abhiru Bhagat and today I am gonna discuss about network security and cryptography. So I hope you will be a great knowledge about it. So our first topic is basic concepts of network security and what are the types of attacks, vulnerability attacks and the encryption attacks, what are the types of it. So in this topic we will discuss about basic definition of the network. That's mean what is network, network security definition and their needs, and the types of attacks. So what is network? In a simple language, a computer network is a collection of computer and devices. That means there are laptop and a desktop, otherwise and the devices is router, switch, hub and any other network peripherals which is connected in a certain pattern. That means in here it is patterns means the topologies. There it is maybe the bus topology, ring topology, star topology, and they communicate with their each protocols. That means we are using some protocols, TCP/IP, and the main routing protocol is EIGRP. That's it. And the protocols are some set of rules that define the how communication is going to happen. That means here it is. This is the main internet. That's mean ISP. We all know the internet means ISP. So how it's work? The ISP send a particular IP to your router, and the router has separate server, switch, hub, IP phone. That means the mobile network connected, and there are several PCs and the others PCs over the other network. This PC has the different network, and these PCs have the different network. So that is the main thing which is different the other networks how to work it. So maybe in that case there is a one user Alice and there is another user Bob. So Alice send a text message to Bob, that is plain text. It means in this text Alice have not used any encryption, and the third user comes Tom who intercept this message and they read this message. So there are no privacy in this message, so easily this message got been hacked, and maybe there is some account number, banking details, password, they stole it and the amount is gone. So our present lifestyle, what is this? That's mean we all use the Facebook or Twitter, WhatsApp. We all live in a social life, but we don't use any kind of vulnerability. We always knew that someone hacked my profile. Someone hacked my profile, but how? Because hacker will know the which encryption is used to be hacked. So careful about it, and the encryption must be secure of this. So network security definition. What is network security? Network security is a protection of the access to files, directories and information and some computer network against hacking and misuse the unauthorized change to the system. That means if we use the network security and protection, that must be protect our personal files, our computer data, just like firewall. We all use the firewall and antivirus, malware protection. In this computer network, we use this, and the hacker will intercept this. My computer, maybe your computer, if any other computer, but they don't get if the firewall is strong, if the antivirus is protected. So the unauthorized file will not be accessed to the hacker. So what are the types of attacks? There are some two attacks: active attacks and passive attacks. So there are some types of the active attack. Interpolation, that is called masquerade attacks, and modification and fabrication. The modification has the two types: replay attacks and alternation. So we will discuss about later. And passive attack. Passive attack is simple: the release of the message content and traffic analysis. So at first we will discuss about the active attacks. So what is active attacks? Active attacks are based on the modification of the original message. Just watch it. Modification of the original message in some manner or the certain of false message. So what is the meaning of it? These attacks cannot be prevented easily. However, the can detect it with some effort, and attempts can be made to recover from them. There are three types, we all know that: masquerade, modification, and denial of service. So what is denial of service? That is a fabrication. Fabrication is a denial of service. What is masquerade attack? Masquerade attack is caused when the unauthorized entity pretends to be another entity. Unauthorized entity pretends to be another entity. Maybe just look at Alice and Bob. There are two users, and the third user is Tom. So Alice sent a message, "Hi, I am Alice," to Bob. When Bob received this message, Tom intercepts. Tom intercepts, and Tom sent that, "I am Alice." That means Alice is actual who sent the message, but the third user, Tom, replaced the Alice who said that, "Hi, I am Alice." So Bob thinks that he is Alice. That means Tom is Alice. That is masquerade attack. There is an unauthorized entity which is pretend to be another entity. What is modification? Modification is the result in some alternation to the original message. So modification result in loss of integrity. So what is the type of modification? We all know that there are two types: replay attacks and alteration. So what is replay attack? In replay attacks, user capture a sequence of events or some data units and resend them. Capture the sequence. Just wait. Here it is Alice and Tom and the bank. There are three users. Alice sent a bank, which is a transaction request, $100 to Tom's account. Just listen carefully. Alice sent a request to bank $100 to Tom's account. After that, Tom's captured this message before sending to the bank. Before sending to the bank, Tom's captured this message, $100. Whenever the data is traveled from there, Tom captured this message and intercept it. Tom again sent $100 transaction again. That's mean intercept this message. Tom intercept this message, $100 to Tom's account, and Tom says again transfer it. That means there is a vulnerability who bank doesn't understand how it is possible. So bank request the access and resend them. What is alternation? Alternation of a message involves some changes to the original message. Similar type. That's mean Alice, Tom and bank. When Alice sent Tom's account $100 Tom blocked the message. Here Tom blocked the message and the message captured. Then again Tom modify the data. Again Tom modify the data and send to the bank. Send it Tom's account $200. So the data will be modified $100 to $200. That is called alternation. The whole data is changed between this process. That is called alteration. What is DOS? Denial of service. Denial of service attacks make an attempt to prevent legitimate user from accessing some services which they are eligible for. That means Alice is the user, Tom is the another user, and there is the bank. So here it is, Alice want to access the bank, like banking server, whatever it is, bank, but Tom obstacle this transaction. Maybe you have see this, maybe there are banking server. When you click on the bank, the server is okay, but transaction is not going. Server bank site is working functionally, but if you send some money to your friend, the transaction failed. That's kind of obstruction. The similar type of obstruction, but not hack, but similar type of transaction. That is called attacks. So the denial of service, that means we don't have any permission to access this bank. That is called denial of service. This is DOS. There are another attacks, passive attacks. Passive attacks those wherein the attacker indulges in the monitoring of data and transmission. The attacker aims to obtain information that is in transit. The term passive indicates that the attacker doesn't attempt to perform any modification to the data. That means in the passive attack, hacker or the maybe the attacker don't change your data. He or she just observe your data. Passive attacks are harder to detect. Therefore, passive attacks should be prevented rather than detected. So, passive attacks is harder to detect because if your data is not going to be changed, you will not be understand that someone hacked my profile or someone hacked my data. If the data will be changed, then you will understand that my profile or my data will be hacked or someone operate to my data. There are two categories of these passive attacks. release of message content and the traffic analysis. So what is release of message content? In this type of passive attack, confidential data of users is released publicly over the network. That means some time of, the hacker or the attacker, your confidential data will be released in public. You all heard about this, the Zoom you have used. Zoom, the maybe the some persons or the hacker attacker and Zoom sell your personal and confidential data to the dark web. That is kind of passive attack. Your personal data will be sold out in a publicly. That is passive attack. And the release of message content, if your confidential data will be released in the public. Data confidentiality is lost in such scenario. Your personal data will be gone, that is your confidentiality is gone. That is Alice and Tom and bank. So Alice sent the bank and their which is the maybe the banking details here, transaction ID, maybe the account number, password, amount name to the account holder name, maybe the transaction ID, all over it is, and the Tom will capture it. Tom will capture the whole transaction details and account details, and they send the details to the dark web. Maybe they are publicly released. So your data will be gone, and your amount, maybe that some amount may be changed, and the whole data is released in the public. Whole data release, the confidential data released in the public. So Tom is the middleman who used this type of release of message content scenario. And the traffic analysis. What is traffic analysis? In this type of passive attacks, the attacker tries to find similarities between encrypted message and find the original content. So few attacker will know that this traffic analysis. Such activity is called traffic analysis. So here it is Alice and Bob. So Alice sent a message to Bob, the encrypted message, which is encrypted, and Tom intercept this message and wants to capture this, but analysis of the data, Tom capture this message, and Tom will know that this message is encrypted. So Tom analyze the data, and if the encryption protection is not so strong, then Tom will intercept it and decrypt the data to the original message. Maybe the protocols MD5 has, there is some other traffic analysis encryption data. So what is the conclusion? Understood what is the network means, network security definition, and what is the main needs of it, and why we need the encryption over the network, because we all used internet and our data is protected, must be protected over it. So the next is principles and cryptography. So in this topic we will discuss about principle of the network security, cryptography. So what is the principle of the network security? Confidentiality, authentication, integrity, non-repudiation, access control, and ability. This is the main 6 network security principles. What is confidentiality? The principle of confidentiality specified that only the sender and the intended recipient should be able to access the content of message. That is confidentiality. That means you all hear about WhatsApp end-to-end encryption. That means sender and receiver will know the actual message. Even the WhatsApp doesn't know that what is the actual message. That is called end-to-end encryption. So that is the type of confidentiality. Confidentiality gets compromised if an unauthorized person is able to access a message. So unauthorized person is able to access this message if confidentiality compromised. That means if we know your Facebook password, so we will, and I have to see your message or personal details. That means the confidentiality compromise. Interception. Attacks cause loss of confidentiality. Interception means I used my network and someone always try to intercept. That means he or she try to block my firewall and break into it to enter my network. That is intercepted. So if the interception attacks is too high, there is the several levels over there, interception levels. If the levels is too high, so my confidentiality has been gone and my firewall has been breakthrough. There are many of users and the server has the different levels of firewall. In our social, in my personal computer, we all use the in a single firewall, but in a corporate way there is a lots of firewall over it. So there is a Alice and Bob and Tom. There are 3 persons. Alice send a message to Bob. Tom intercept this message. That means Tom read this message. That is called confidentiality. So what is authentication? Authentication mechanism helps establish proof of identities. The authentication process ensures the origin of an electronic message or the document is currently identified. Verify your data and then grant the access. Alice, Bob and Tom. Alice sent to Bob, I am Alice. Then Tom access the data, hi, I am Alice. And after that, if the authentication fail, then it will be blocked. So what is integrity? When the content of a message are changed after the sender send it, but before it reaches the intended recipient, we say that the integrity of a message is lost. That means modification cause loss of the integrity. Alice and Tom and Ben. Alice send a message to Tom account, the bank, but message don't receive the bank. Alice send the message, but before it's reached to the bank, Tom alter it and intercept it. Then change the value $100 to $200. That is integrity alterate the data. Non-repudiation. There are situations where a user sends a message and later on refused that she had sent the message. The principle of non-repudiation defeats such possibilities of deny something having done it. Non-repudiation doesn't allow the sender of a message to refute the claim of not sending the message. Alice Bank Alice transfer the amount to the Tom's account via bank, that is $100, but the I didn't transfer the money. So I didn't transfer the money. Who said this? I didn't transfer the money. That is Alice says. Alice says that I didn't transfer the money, but actually the transaction has been successfully. But after that, the non-repudiation effect is when the transaction has been. You all know that maybe you recharge your mobile number. But it's deduct your balance. From your bank, but not receive the Airtel or Aircel or Jio, whatever this company, to get the amount. So bank deduct your message, but the Aircel or Airtel will not receive the amount. That is non-repudiation. After the few days, 3 or 4 and 7 days, before 7 days, the amount will be refunded to the bank. That is non-repudiation. What is access control? The principle of access control determines who should be able to access the data, and access control mechanism can be set up to ensure this. That's when we have a lot of user, but I give it to the permission of some user to make the administrator user or the host user. Access control is broadly related to the role of management and the rule of management. Role management concentrate on the user side. Rule management focuses on the resources side. So Alice, Tom and the database. There are 3 types. After that, Alice admin access database. So here the Alice is the admin who can access the database. But if Tom wants to access the database, user cannot access the database because Tom doesn't have any privilege or any role of access permission to access the data. That is access control. So what is availability? The principle of availability states that resources should be available to unauthorized parties at all time. Interruption put the availability of resources in danger. So that means Alice, Tom and bank. Alice access the bank and Tom send that totally obstacle, doesn't access any privilege to the bank. That is totally authorized party but don't access it. Tom obstruct this data. That is availability. So here we will discuss about some cryptography. Here it is Alice, Bob and Tom. There are three users. Alice send a plain text that is called ABC. He write the text is ABC. After that, he converted the message to be encryption protocol, which is the ciphertext encryption. The cryptography encryption type is ciphertext. So after the ciphertext encryption, that ABC replaced by CDE and get overthrough the internet, and Tom intercept the data. But Tom doesn't know what is CDE, because he said that actually ABC, but Tom received it is as CDE. So Tom don't understand, and after this, the Tom, who is the attacker, don't attack the this actual data, and before the data will be encrypted, and this is the encryption side and this is the decryption side. The decryption side is after the data, it is CDE replaced by the ABC and receive the Bob, the actual message. So whole data is protected, just a single ciphertext encryption. That is called cryptography. So in that test, the cryptography will be affected. So what is cryptography? Cryptography is the art of achieving security by encoding message to make them non-readable. Clear text, plain text. Clear text and plain text signify a message that can be understood by the sender, the recipient, and also by anyone who gets an access to that message. When a plain text message is codified using a suitable scheme means is the suitable cryptography. The resulting message is called ciphertext. Ciphertext is the type of cryptography, and it is readable only by those who know the encoding and decoding process of the particular scheme. This is a very important thing. If I encrypt the message with some encoding techniques, the receiver must know that what is the encoding script, and the actual encoding script will be decoded the process. Who know the encoding and the decoding process, that particular scheme, that must be important. Encryption is a process of converting plain text to ciphertext using some encoding scheme. Decryption is the process converting the ciphertext to the plain text using some decoding scheme. So cryptography techniques, there are two types of techniques. One is substitution technique, another is transposition technique. So what is substitution technique? In this technique, the characters of the plain text, the character of a plain text message are replaced by other characters, numbers or symbol. That means the actual plain text message will be replaced the another characters or number or symbols. And what is transposition technique? In these techniques, the character of the plain text are scrambled amongst themselves in the some order to get ciphertext. That means, just wait, we will discuss about later the transposition technique. So here we will start about the substitution technique. If the text is ABCD, so it will be replaced by 1 2 3 4, or here it is the another symbol that is replaced by the another character which is not relevant to the this character. And the transposition technique is, it is scrambled among themselves in some order to get the ciphertext. Scramble the order. That means if the text is ABCD, it is scrambled BADC in this order. That is called transposition technique, and it is called substitution technique. So in this substitution technique, there are some encryption process. One is scissor cipher. So in this topic, we will discuss about how scissor cipher works, how the encryption and decryption process of the scissor cipher, and the example. So scissor cipher technique. It is a simple substitution technique working an encryption. So what is this? Each alphabet in the message is replaced by another alphabet 3 phase down in the line. That is the encryption process. And what is the decryption process? Each alphabet in the message is replaced by another alphabet 3 phase up in the line. So how it's work? If this ABCD, if the text is ABCD, so after the A, 3 phase down, that means after the A, what is BCD? So the first letter is, so replace A, after the replace we will get the D, and after that B. So what is the replaced value of the B? 3 phase down, C, D, E. There is a 3 phase down, that is called E. So in this process, A is replaced by D, B is replaced by E, C is replaced by F, and D is replaced by G. So that is actually work. And the same way decrypt it. 3 phase up. If we look about the 3 phase up, so the D is replaced by A, E is replaced by B, F is replaced by C, and G is replaced by D. That is simple. So here is the encryption process. A plus 3T. It is a simple table of the encryption process. Just wait, here look into it. Last X, Y, Z. Here it is. Just wait. X plus 3. That means Y, Z, and it start again to the A. It's totally the plus 3 process is rotated with the alphabets. If the text is last one is Z, then after that it is come from A, B, C. That is encryption process. And the same way it is decryption process. The D, E, F, G, and minus 3, that alphabet. The minus this, it is so simple. So, scissor cipher example. Alice, Bob, and Tom. Alice sent the text ABC, and it is encrypted by some scissor cipher text. That encryption process is plus 3. Every text which is had a letter, that is plus 3. So A is replaced by D, B is replaced by E, and C is replaced by F. After that, hello.
Hello, sir.
Yes,
Hello,
yes.
sir. Can you please say me that how can I make myself anonymous while searching on the dark web?
Um, Actually, this is totally for the part of the ethical hacking. So, in this session, we will not discuss about the ethical hacking and the dark web and the masquerade attacks.
Acha. Okay, sir. I
Okay,
got it.
okay, okay. So, Alice sent a message ABC, and after that, the Caesar cipher text, that is the encryption process, we will get the DEF, and then the whole message will be encrypted and send it over to the internet. And as the same process, Tom wants to intercept it, but Tom don't know the what is the encryption is the DEF. So the message is securely received to the Bob, and the same decryption process, the -3. That is the DEF. So D -3 is A, E -3 is B, and F -3 is C. And Bob is the message successfully Bob received this message. Actual they got the message. So here is the problem. So you have to solve it. Here is the problem. I have given to you the 3 minutes. So that is the encryption and decryption process to the successive effect. This is the problem. I love this is actually message. I love network security. So solve this message and send it to the chat list. The Caesar cipher is the default shift key is +3 and -3. The, in the encryption is the +3. It is the default key. It's not a manual key that has the +3 and the +2, but it is the default key, shift key. It is a +3. That is the Caesar cipher. Okay, just checked it if the message is correct. Check the value. Okay, Devajyoti. Okay, Rohit. Okay, so the actual encryption message is L space. The space must be given to it because here it is a space. That means here it's also received a space. Okay, and the decryption process is -3 to get the actual message. So the encryption is the who's said the encryption. It is the sender. This part is for sender and this part is for receiver. There is a two type. Okay. So after this we will be the changed another substitution technique, that is a modified scissor cipher. It is a modified scissor cipher. So what is the modified scissor cipher? Maybe you assume that what's gonna be happen. So we will discuss about the what is modified scissor cipher and what are the types and the encryption and decryption process of the modified scissor cipher. So in this substitution technique, there is a key which is the range 1 to 25, that is called modified substitution. There is a key. Each alphabet in the message is replaced by the another alphabet which is the key placed down the line. That means the range. If I range the range is selected 1, so the it's down only one line. If the set round is 25, so it's down the line at the 25th character or the alphabet. So if the shift key is A, B, C, D, so the encryption process is changed by the shift only one key, that is the A decrypt the B, and B is replaced by C, C is replaced by D, and D is replaced by E. And the decryption process is each alphabet each alphabet in the message
So, sir, how will we understand that when shall we apply this simple substitution technique or when to apply that previous one?
Okay, this is not a think about yourself. It is the protocol and it is used by the algorithm which company and the which process it will be encrypted. If you want to do your network security too high, that is called security. So scissor cipher is the below level security. Modified scissor cipher is the so high level. So obviously you wanted to secure your machine. It's very strongly. So you must be modified scissor cipher technique used,
Hmm.
because everyone
Then,
knows that. Yes.
then in case of modifying, we will use this simple substitution which is encrypted just by one value.
Modified cell cipher is encrypted. The value is the range is 1 to 25. It's the value is 1 to 25. I can shift my range any number of these. Okay, but
Okay.
the
Okay.
Caesar cipher has the default value only plus 3. That is everyone knows it. So everyone decrypts message
Okay.
easily, na?
So I'm asking that only that if we are going to just decrypt any encrypted message or encrypted data, whatever, so how will we understand this that it is encrypted by how much range value? Is it
Then
about the algorithm we shall make out?
yes, it is only make through who encrypt the message and who decrypt the message. Encryption
Okay.
process must be dependent on the decryption process, and decryption process must be dependent on the encryption process. If the encryption process is the Caesar cipher and the decryption process is modified Caesar cipher, it won't work. Must be in the
Got it.
must be it is the same
On the
algorithm.
same platform.
Yeah, same algorithm,
Yes, I got it.
because
And
in the
yes,
yes.
my other question is about when we were about to start our webinar, you just said about the firewall protection.
Yes.
So, what will we do if we need to break a multiple firewall protection, which is breached, suppose to 7 or 8 layers of firewall protected walls?
That is a totally ethical hacking part. So we
Okay.
should we not discuss about here.
Okay, I got it. I got it.
Okay.
I got it.
So the decryption process is each alphabet in the message in the replaced by the another alphabet, that is K. K is the range which is value 1 to 25 and placed up to the line. It's a simple process, that is the reduced the value. So let's example, just look into it. Alice and Bob and Tom, there are 3 users. So Alice set the K value. Just watch it. Alice set the K value is 5, and after that Alice sent the message a plain text which is ABC, and the modified scissor cipher technique, the K value is replaced by the original text is A plus 5. It is F. A plus 5, that means A plus K. A plus K, that means A plus 5, it is F, and B plus 5, it is G, and C plus 5, it is H. So the modified scissor cipher technique, it is used by the default. It's not used the default key, it is used only the key which the user has been stated. And the same process, the data will be gone through the internet and Tom intercepted, but Tom don't understand what is the FGH. So Bob received the actually message without any interruption. But it is the main function, the K5, it is the main function, that is the modified shell cipher. So solve the problem. If the assumed key is 5, modified shell cipher. So I love network security. Assume the key is 5. So solve this. Assume the key is 5. Okay. Okay. So check the value, and after the serial cipher text, N space QTAJ space AJYPTWP space XJHZWNYD. Okay. So after the text, it is the encryption result and the decryption result. Okay. So there are another substitution technique which is called yeah.
Okay, sir, we are doing only about the alphabetical parts of encryption and decryption. So, what will we do if there are a mixture of numbers in the message? Suppose I have 3 seats booked. So, I have 3 seats booked in this phase. If 3 is the number, so how can this number 3 be encrypted?
Okay, that means you have to say that alphabet, not only alphabet, is the maybe on number on symbols.
Yes, sir.
Okay, that is not in this encryption process. There is a several another encryption process. So we will discuss about later for the following slides. Okay. So another substitution technique is polygraph substitution technique, which is used in a Playfair cipher. Just note down this.
Sorry, sir, straight to hear you.
It is another substitution technique, polygraph substitution technique, that is Playfair cipher. Playfair cipher. Just note down it. Playfair cipher. So what is the polygram or polygraph cipher? That is Playfair cipher. So we will discuss about encryption and decryption process of Playfair cipher and the problems. So what is polygram or polygraph cipher? So it is the substitution technique. Block of plain text. Block of plain text is replaced to get another block of cipher text. That means block of plain text is replaced to get another block of cipher text. So how it's work? A block plain text is ABCD might be replaced with ZXAB. But where is the another block is ABC, it will get replaced by a totally different block, not XZA, because the block is not set only single character. So after the picture we will read concept. Playfair cipher, block substitution cipher, encryption and decryption. Two block of the two character at that time. Two block of the two character at that time consists of a keyword that is agreed upon both sender and receiver. So encryption process. So let's have a keyword puzzle. So step 1, create a 5 by 5 matrix. Since only 25 alphabet can fit in the matrix, we combined I and J and represent as I. That is the actual step. We must need 25 alphabet because we all have the 26 alphabet in the total, but if we had a matrix, it must be 5 by 5 matrix. And after that, that one alphabet, because the total alphabet is 26 and the 5 by 5 matrix is a 25 alphabet, so the one alphabet is left. So in that case, the protocol has been set the combination of the order that combined that I and J represented only I, which is not set in the keyword puzzle. So write a keyword puzzle and the first set from the left to write excluding the repeated letters. Note down that if the keyword is puzzle, in the first page from the left to write excluding the repetitive letter. So how it's work? First of all, the keyword will written on the matrix and top of the PUZLE. So why we write PUZLE? But the actual word is PUZZLE. So if the word is repeated, note down, write to exclude the repetitive letters. That means if the double Z is appeared, it's except only the single character. That means only single Z. That is PUZLE. And fill the remaining space with the alphabet A to Z, which not occur it. That means A, B, C, D. Look out. Here we already in the puzzle have E letter. In the puzzle have E letter, so we escape the actually E and write down the F directly. And the same process we exclude the P, U, Z, L, A, B, C, D and then F. G, H, I and J has been combined to the directly I. I and J is directly combined and presented as a I. Then K, L already represent in the puzzle word. Then M, N, O, P is represented in a puzzle word. Q, R, S, T, U is also represented in a puzzle word. V, W, X, Y and Z is also represented in a puzzle word. So all the alphabet has been set in this encryption process. So how we encrypted this message? If the message, it is a totally structure, it is a total structure. If the message is network security, if the message sender wants to send the network security, so how will we encrypt it? Note down, eliminate spaces and add X between two consecutive similar alphabet. Eliminate spaces and add X between two consecutive similar alphabet. If number of alphabets is odd, if number of alphabet is odd, then add X at the end. That means the block alphabet, it's set as the 2 alphabet. The final message is X. Why? Because the block of alphabet is NE, TW, OR, KS, EC, UR, IT and the last letter is only single. There is a single. That's why the eliminate space has been add the X to the last letter is YX combined with the block letter. So what is the encryption rules? Rule 1, same row. If both letters are in the same row, replace them with the letter on the right of the letter. And if the letter is on the end, go back to the start of the same row and use the letter to replace with the end letter. Same as same column. If the both letters in the same column, replace them with the letters below them. From the letter is on the bottom, go back to the top of the column and use the letter replace with the bottom letter. And the rule 3, if neither of letter are the same row and same column, imagine creating a rectangle with the two letters on the opposite corner. Write down the other two letters on the other corners of the rectangle. So let's have a look how it's work. So as we know, the encrypted message is network security X. So how it's work? So it's a block. So there are separate have a two block. So first text is NE, second is TW, and the rest of this OR, KS, EC, UR, IT, and YX. So what is the rule? NE. So first plain text, that is NE. So you have to take a snapshot. You have to take a snapshot of the rule. Then you will be understand actually what happened it. Okay, you have to create a snapshot. Have you all done? Okay, so we will start it. So what is the third rule? If neither of the letters are in the same column or row, imagine creating a rectangle with the two letters on the opposite corner. Two letters of the opposite corner. So first letter is N and the second letter is E, opposite corner. So then just it is the rule of 3. Third rule, imagine the rectangle. So if the imagine the rectangle N and E, that is the opposite corner, so it is replaced by PS and the written as the same process. So N is replaced by S and E is replaced by P. So that is the SP. As the same process, next text is TW. So it is the TW. So what is the rule? The rule number 1, if both letters are the same row, replace by with the letter right of the letter, and the letter is on the end, then go back to the start of the same row. So if the letter is the same row, then follow the right letter. So T replaced by V and W replaced by X. Similarly, after that OR. So OR is simple as that, followed by the same process. So Q and S. After that, that is KS. So as the same process, create that is the third rule, create an imaginary rectangle. Third rule, create an imaginary rectangle. So K is replaced by M and S is replaced by R. Just simple as that, the diagonal value. After that, EC. So create an imaginary rectangle and the E is replaced by Z, C is replaced by F. So the value is ZF. After that, UR is the message. So UR in the row and create an imaginary rectangle. After that, U is replaced by L and R is replaced by O. So that is LO. And similarly, IT. So imaginary rectangle, I is replaced by G and T is replaced by W. So it is GW. And the last one, that is XY. Just watch it. In this case, X, what is the rule? Is the rule number 1. It's a rule number 1. So it is the same row. So the letter on the right of the letter. So the X's right of the letter is Y. X's right of the letter is Y. But Y's right of the letter, what is the Y? It don't have any right of the letter is Y. But it has. Rule number 1, watch it. If the letter is on the end, that means Y. Go back to the start of the same row. Go back to the start in the same row. That means Y's right letter is T. So the value is T Y, because Y's right letter is T and X's right letter is Y. So the value is T Y.
Okay, sir.
Yes.
So, in every encryption letter, we should write on the above block this puzzle format and then solve the encryption.
There is a Playfair cipher format.
Okay.
There is a lots of cipher text, and there is a one part of the Playfair. So Playfair is used in the matrix type.
What if J is encountered?
Playfair ciphertext is used the metric type.
Sir, what if J is encountered?
What is J? J is encountered.
J.
Because in this matrix we have the 5 by 5 matrix. It is a default matrix. 5 by 5 matrix. So we have total number of alphabets is 26. We all know that we have total number of alphabet is 26. But in the 5 by 5 matrix we have to input only 25 alphabet. But we have 26 alphabet. So one alphabet is extra. One alphabet is extra. So in this ciphertext, as the protocol and the rule of the is that I and J combined as a J. As a I. I and J is combined as a I. Look at it. The I is totally middle of the puzzle. That's why it's only I and J, not A and B is replaced by A. Because I is the middle of the puzzle. That's why it's used is this protocol.
And the keyword puzzle, is it fixed? or it can be
No,
anyone.
no. Keyword puzzle is choose the encryption process. That means previously I have said the key is 1 to 25. That's a range in the ciphertext, modified ciphertext.
Okay.
That
Okay.
that we set the range, that the user set the keyword set, that is puzzle. Puzzle is the like token key. We all know that the token key.
Yes.
That is the token key. After the token key, we'll access the actually message. Just like OTP, OTP is the access
Yes.
message. That is.
And sir, this token key must be different for different messages.
Yeah, different for different message. To encryption to decryption, its message is, and the token key, that means is keyword is same. We encrypt the message.
So
If we encrypt the message is the puzzle key, it must be decrypted with the puzzle key.
So, sir, before decrypting any encrypted message, we must need a person who has a relation with the encryptor of that message and
Yeah.
knows about that encryption.
No, he don't need to know about the encryption. Encryption is the process with the use of the algorithm. He just choose which encryption process he wanted to use.
No, I got that. What I was asking is that just before decrypting any encrypted message, whose encryptor we don't know, so we must need a person who is well in relation with the encryptor or the encrypted message, who can give us the access code for those particular
Yeah,
messages.
yeah, yeah. Oh, yeah. He must know.
Okay.
Okay. After that, the decryption rules. So take a snapshot of these rules. This is rule number 1. If both letters are in the same row, replace them with the letter on the left of the letter. Just wait and watch. Left of the letter. Previously, what's it? It is the right of the letter. So that means it is a decryption. It is the left of the letter. That is totally opposite. Another is if the letter is at the start. So previously we said that if the letter is the end in this decryption process, it is on the start. Then go back to end and the same row. Use the letter and replace with start letter. Rule number 2, if both of the letters are in the same column, replace them with the letter above them. If the letter,
Sir, if you kindly remove the pointer, if you kindly just shift the pointer.
okay, is it okay?
You.
So rule number 2, if both of the letters are in the same column, replace them with the letters above them. If the letter is on the top, go back to the bottom of the column and use the letter to replace with the top of the letter. And rule number 3. Rule number 3 is if neither of the letter are in the same row and the same column. Imagine creating a rectangle with the two letters on the opposite corners. Write down the other two letters on the other two corners of the rectangle. So, in this case, the decrypted message we got that previously SP, VX, QS, MR, ZF, LO, GW, and TY. So, the ciphertext we got that SP, VX, QS, MR, ZF, LO, GW, TY. So, how will we describe it? The first ciphertext is SP. So it is a rule number 3. create an imaginary rectangle. After that we got that SP. So S is replaced by N and P is replaced by E. So we got that N. After that it is a VX. VX. So we all know the rule number 1, the left of the letter. Actual message to decrypt the left of the letter. So V's left of the letter is T and X's left of the letter is W. So it is the T and W. And the similarly QS is also is O and R. O and R. QS O and R. After that MR. MR create an imaginary rectangle. M is replaced by K and R is replaced by S. So it is a KS. After that ZF. So ZF create an imaginary rectangle. It is the rule number 3 and set is E and C. Z is replaced by E and F is replaced by C. Then ciphertext is LO and it is LO. So replaced by L by U and O is replaced by R. It is a U and R. And GW. So GW is IT. G replaced by I. W is replaced by T. It is a IT. And after that T and Y, that is the actual letter. T and Y, that is the actual letter. So as we know that if the letter is at the start, go back to the end of the same row. So Y's left letter is X. We all know that Y's left letter is X. So T's left letter, it's rotate as the same process So T's left letter is Y. So that's the actual process. So we got that actual value is network security and the last value is X. It is only working for encryption and decryption process. After the decrypted the message, X will be deleted of this message, original message. After decrypted the message, X will be removed at the end. So another polygraph substitution technique is, so first one is Playfair cipher. So this one is Hill cipher. So what is Hill cipher? Introduction and process of encryption process and decryption process of Hill cipher. Hill cipher is a polygraph substitution technique which is based on linear algebra. Hill is used matrix and the matrix multiplication to mix up the plain text. Here's some mathematical calculation. In the polygraph substitution cipher, plain text letter are substituted in the larger groups instead of substitute letter individually. So what is the encryption process?
Sir, again you can't be heard.
Hello? Am I audible? Hello? Yeah. Okay. Maybe your audible device is not working. Yeah, someone is texting me to audible. Okay. So, what is the Hill cipher encryption? There is some steps. Step 1. Agreed upon 2D matrix of any size as long it's a square. So we all know that in the square matrix, there the key of the matrix is shown as the key, and it's the diagram of 3 by 3, 3 by 3 matrix. Step 2. Assign 0 to 25 to the English alphabet A to Z respectively, or any. Step 3. Word to be encrypted A double T. That means we work about the word is the actual messages.
Sir, I can't hear anything. Please.
But I am audible and someone will text me. I am audible. Maybe your device. You have to close the session and reconnect the session. Maybe you will be done. Okay. Step 4. The converted A double T. That is the actual message. The converted A double T to numbers in the matrix form. A double T to 0, 19, 19. So how will I get the 0, 19 and 19? Just you can do it. Assign 0 to 25. Assign 0 to 25 letter English alphabet as A to Z respectively. That means A is replaced by 0. T, calculate your finger. T is replaced by 19. Calculate your finger. So, convert ATT to numbers. Convert the ATT actual message to numbers in the matrix form is ATT is used by 0, 19, 19. After that, step 5. Perform matrix multiplication and take mod 26. In order to multiply to be matrix A and B, numbers of columns A must be equal the number of rows B. That is the mathematical equation. That is the mathematical equation to matrix multiplication. There is the formula of the A matrix must be equal to the number of rows of B matrix. So there is a formula. So let's assume there is a square matrix of 3 by 3, which any number of matrix, that is it is the key matrix. So if we use the key matrix, that is the previously we used that key text is puzzle. So here it is the key matrix, like any kind of matrix that to be encrypted any message. So matrix multiplication, that is a matrix, and the ATT value is here. ATT value is here. After that multiplication, what is the process? That is the process is 2 into 0, 4 into 19 and 5 into 19. That is the matrix multiplication process. So I will discuss later. And the depletion process. And the same process, if calculate the K inverse, it's totally mathematical part. You have to know about the matrix multiplication and the inverse matrix, adjoint matrix. Calculate K inverse of the key matrix. The important thing to know inverse determinants of the matrix and the matrix adjoint. Step 2. Convert the encrypted message into its corresponding number format. matrix is PFO. Corresponding number format is PFO. So that is last one I get the matrix in the encryption message. It is a PFO. That is a called, you can call this is a ciphertext. You can call this is a ciphertext to the plain text. That means ATT. If the ATT is the plain text, then we get the ciphertext is PFO. And after that the PFO replaced by the number, P is replaced by 15, F is replaced by 5, and 14 is replaced by O. And the same process, the matrix multiplication process with the K inverse, and K inverse into PFO. PFO means the value, and after that take mod 26 to get back the original plain text message. So the actual message will look like this. So you need to mathematical calculation. K inverse into the value. How it look like? K inverse into, here the into, and 15, 5, 14, which is the PFO numerical value, and then the into mod 26. After the mod 26, we will get the actual value 0, 19 and 19, which is represented at a 0 is A, 19 is T, and 19 is T. So in this process, Hill-Seymour process, that is a totally mathematical process. You need to know very well about the matrix multiplication. So another polygraph substitution technique is called Varnam cipher. It is the name of Varnam cipher. So Varnam cipher, encryption decryption process and example will be discussed about it. So what is Varnam cipher? How it's work? Varnam cipher is based on the principle that each plain text character from a message is mixed. One character from the key stream, it is a polygraphic cipher is any cipher based on the substitution using multiple substitution alphabets. And the third one is, in modern terminology, a Varnam cipher is symmetrical stream cipher. That is the term. It is a term symmetrical stream cipher in which the plain text is combined with a random stream of the data. The key stream of the same length to generate the ciphertext. That means Varnam cipher has the one key stream. That one key stream is called a OTP. If the plain text is hello, then the key stream text must be implemented. That is called OTP. The XZAPQ. So why we use this OTP? The OTP can be changed anytime, but it must be same order or the same. If there is a 5 character, here is the 5 character, so OTP must be used in the 5 character. So encryption process. If the numbers represented as the alphabet, so we get the A is represented as a 0. It is a totally 0 to 25 value. A to Z, 0 to 25. That is the value. So how will be used? Treat every alphabet of plain text as number in proper order. Like A is 0, B is 1, C is 2. Convert the one-time pad. That means OTP. One-time pad means OTP. Convert the one-time pad text to its corresponding number by following step 1. add plain text number to the OTP number. If the total is greater than 25, note down, greater than 25, subtract 26 from it. Convert the final number to the individual alphabet again to get the final ciphertext. So have a look. If the problem of the text is hello and the one time pad is DAZMP, so how will you look? If the text is hello and replaced by the number, so H is replaced by, look this, H is replaced by 7, E is replaced by 4, L is replaced by 11 and O is replaced by 14. So as we write the same procedure with the OTP. So D is replaced by 3, A is replaced by 0, Z is replaced by 25, M is replaced by 12 and P is replaced by 15. So how it's work? After that, the total number, that means the plain text and the OTP text, converted the number and then add it. So after the addition of this number, what will get? 14 plus 15 is 29. 14 plus 15 is 29. 11 plus 12 is 23. 11 is 25 is 36. 4 plus 0 is 4. 7 plus 3 is 10. So here we got that. Number 3. If the total is greater than 25, if this is the total, if the total is greater than 25, because we all know that the last number of the value is 25. So we cannot write any number which is greater than 25. So the subtract 26 from it. So subtract 26 from it. So here's the only two numbers which is greater than 25 and subtract it. So after the subtraction, 29 minus 26 is 3 and 23 is under 25, so it is as it is written on this. After that, 36 minus 26, it is 10, 4 and 10. That is the actually ciphertext. We got this, and it is converted as the alphabetically. So 10 is represented K, 4 is represented as a E. After that, 10 is represented as a K, 23 is represented as a X, and 3 is represented as D. So KEKXD, it is the cipher text. So what is the decryption process? As the same, convert the cipher text to its equivalent number from using same method like encryption. Convert the one-time pad text its corresponding number by following step 1. Subtract OTP from the ciphertext. If the total number is negative, add 26 to it and convert the final number to the individual alphabets again to get the final ciphertext. So we all know that ciphertext KEKXD, that is previously we got, and the one-time password, the key token, it's always same, encryption to decryption process. So as the same thing, solution, what is this? KEKXD. So as we written on the numerical type, 10, 4, 10, 23 and E. So 10 is represented at K, as similarly 4 is for E and K is 10, X is 23 and D is 20, D is only 3. D is only 3. After that the one time pad D, A, Z, M, P. So similarly it is look like 3, 0, 25, 12 and 15. And what is the process? Subtract OTP number from ciphertext. Subtract OTP number from ciphertext. So it is a ciphertext and OTP number. Subtract. After that we got, you can do subtract OTP number from ciphertext. So from ciphertext, that is 3. 3 minus 15. 3 minus 15. That is minus 12. 23 minus 12 is 11. 10 minus 25 minus 15. 4 minus 0 is 4. 10 minus 3, 7. So we all know that ciphertext, and if the total is negative, then add 26 to it. Add 26 to it. So here we got the only two numbers which is negative number. So we cannot write any negative number because we don't have any negative number on the alphabets. So add 26 it. So we got that number. Minus 12 plus 26, it is 14. 11, as it is written on this. Minus 15 plus 26 is 11. 4, 7 and 7. That is written. And after that convert the final number individual alphabets. So convert the final number. The 7 is represented as H. 4 is represented E. 11 is represented L. And 14 is represented O. So as we know that previously, and when the encryption of the plain text, that is hello. So we got the actual hello text. And their all substitution technique has been set, and after that there is another technique which is I talked about previously, that is a transposition technique. So transposition technique, it is an advanced technique, is rel fence cipher. It is a very complicated rel fence cipher. Rel fence cipher and encryption and decryption process of this and example sum. So what is rel fence cipher? Rel fence cipher technique is a transposition technique that follows a simple rule for mixing up the characters in the plain text to form the ciphertext. Simple and easy to crack, hence used along with some other cipher technique. So what is the process? Firstly, you need to have a key. In every encryption process we need to have a key, which for the rel fence cipher is the number of rows you are going to have. Write down the plain text message as the sequence zigzag. So rel fence cipher is also known as the zigzag cipher technique. Rel fence cipher technique, and it's also known as the zigzag cipher technique. So what is it? Write down the plain text message as the sequence zigzag of diagonally down to right. Diagonally down to right until you reach the number of the rows specified by the key. Number of rows, just look into it. Until you reached the number of rows specified by the key, then bounce back up diagonally until you hit the first row again. Read the plain text written in the sequence of the row. So it is a plain text which has the word is encryption. And what is the count? Count, it is the, if we broke the encryption letter, you count, it is the ENCRYPTION. It is a 10 letter, that is called count, that is a 10 letter. And the key is the row. We know about the row, it is the key. So here we write it, the how is the process, it is the diagonally down to the right, so it is a row 1 and it is a row 2. So first one we read in the row 1 E, and down to right after N, it is written on this down to right, it's E and N. After that we say that if the row has been reached, there is the last row we have reached N, so bounce back diagonally until you hit the first row. So diagonally, so C is look like this, so it is look like same process, ENCRYPTION, that is the encryption. This way we look like this. And the finally we got the ciphertext. How we get this ciphertext? So the step number 3, read the plain text written in the sequence of the row. Read the plain text written sequence of the row. That means first you need to write the row 1. If we write the row 1, what we get? First ECYTO, then ECYTO. Okay, so someone is taking me to show the rules. This is the rule. You need to set a screenshot. Okay, so encryption diagonally. After that, I will get row number. So rule number 3, read the plain text written in the sequence of the row. So first row we have seen this ECYTO. So we write the ECYTO. After the row 2, what we row 2? NRPIN. After that NRPIN. So the encryption was as represented as a ECYTO NRPIN. That is the Ralph cipher technique on the basis of key 2. After that, if we use the key 3 on the same text, so how it look like? Same process. Here it is row 1, row 2 and row 3. There is a 3 row. So first we write the E diagonally until you reach the row. So ENC. Here this is the last row and diagonally up into the first row. ENCRYPTION. So here just look into it. If we create a large number of key, we don't need to changes any table number or count number. count number is always same, because every number set in the different column, because the number written on the column wise, not row wise. This is the column. In every column set on the just one alphabet. That's why we don't need to change any table number. That's why we all has 10. After that we got ciphertext. How it's look like? The rule number 3. Read the plain text written in the sequence of the rows. So that is the first row we have written this EYO. EYO, that is the first row. After that the second row. Second row is NRPIN. NRPIN. After that, third row, it is CT. It is CT. Look, the both ciphertext. It is different. It is different only for we use the key. It is different only for we use the key, because here it is rule number. This key is 2, this key is 3. That's why the total ciphertext has been changed. If we use the 5, then ciphertext has been changed. So what is the decryption process of the ring fence cipher or zigzag cipher? Ciphertext is, we got for key 2 ciphertext, we got key ECYTONRPIN. We got previously, that is the ECYTONRPIN. ECYTONRPIN. After that, the same process, but in the decryption process, it's look like row wise. It is look like row wise. E C Y T O. But after that, N R P I N. It is look like this. After that, got the actual value. E N C R Y P T I O N. That is the actual value. And the same process of the for P3. E Y O, the first row. After that, second row, N R P I N, and the third one, C T. So the final value of the decryption is ENCRYPTION. The total values is encryption. So I hope you will be understand about the network security and the total part of the. Do you have any questions? Okay. So tell me in what which part don't you understand the fair? You need to tell directly. Don't write it. Okay. If the keyword is India. Okay. Just wait. And I come first. Okay. Look. Your question is the if the keyword is India. So here it is the keyword. So keyword is India. So INDA. Then it will look like B, C, D, E, F, G in that process, and the I is obsolete. Have you get my point?
But sir, when in that case of the access code being India, I is given at the first block, so J will also be covered in that first I, right?
Yeah, first time.
Okay.
In that case, if the 5 by 5 matrix,
One more question is that if X is the last alphabet
what is
in an odd number of letters,
odd number letter in the playfair cipher?
last, yes, letter center, last letter is X.
Just wait. Last number of X. You want to tell this, no?
Is the last letter is X for odd number.
Just wait. Okay. In that case, is the last final text letter is X.
Yes.
Okay. So in this case, why you need to write this X? Because in the playfair cipher need to change their letters with a block type. That means it wanted only two minimum, at least two letter.
No, no, I mean that the last letter is X. Do I have to put X again?
No,
If it is odd.
no. Then we need to put that text which not written on the final text message. That means in the network security it don't have any X, and
So
the
for example, I choose a word with X.
okay, listen, why we need X?
If I
Because in the message I don't have any X in the final message, and I don't have any X in the puzzle message. So we write in the totally separate letter. Have you got my point?
yes,
So sir,
I know I mean
I
Yeah, tell me. Hello.
So sir, I can just select any random alphabet except that access code keyword and the message keyword, right?
Yeah.
Okay.
Random alphabet. It must be used on the last of this message. If we need it, it's not necessary to put into it. If we need it,
Yes, only when it will be odd, then we will use it.
Yeah. Okay. Any questions? Okay. So can we close this session? Okay. Thank you.
Thank you, sir.
Thank you.
It was very fruitful for me to join this webinar.
Thank you.
Special thanks to you and our department.